As we are starting with geography optional lectures today, so first of all, I'll give you a brief idea regarding this particular subject. Right? As you have chosen geography as your optional, so you should know what exactly is the task which is there ahead. Right? To clear one doubt among all of you, I know this will not be a doubt, rather you would be knowing this, that geography is a quite big subject. Right? Geography is quite huge, but we'll make it small. We have certain like during our course, during our syllabus, completion of syllabus itself, I'll tell you how to integrate various topics together. See, what happens is, if you see geographical concepts individually, then geography would it would look as if the syllabus is quite vast. The syllabus itself, you would see that syllabus is quite vast, but then there are various interlinkages which are there with like within the subject itself. Right? If we interlink those topics together, then the subject would be, we can squeeze subject quite substantially in such a way that you would be able to revise geography within 5 to 6 days, and that is quite good. Like that is okay. If you can revise a particular subject within 5 to 6 days, then that's okay. Okay. Then second is how we are going to go about that particular subject. How we are going to discuss in this entire stretch of 4.5 months. How we are going to finish this syllabus, right? See, first of all, you must be knowing this, that our class would go from 1 to 4, so it would be 3-hour classes. So last time what we have done was, we used to conduct classes for 2.5 hours. Every day the classes used to be there for 2.5 hours. But then I have realized that during the course itself, I have realized that after 2 hours, the concentration level of students, that there is some, because see, geography is quite intense, so there are a lot of concepts which are involved, and then you have to interlink a lot of concepts together as well. So concentration level goes down a bit after 2 hours. So that's the reason because of which what I have done is, I have kept classes for 3 hours, but then after 1.5 hours, you would have a break of 5 minutes, 5 to 10 minutes, and then again we'll have class of 1.5 hours. So that ways we'll be able to finish syllabus on time as well. At the same time, you would be able to maintain your concentration in the class. In case you miss out any particular class, don't worry about that. But see, that should not be a routine obviously. But in case if you miss out certain class, then don't worry about that. That video would be provided to you. But that should not be a regular routine as such, okay? But still, we'll do that. For online students, there is a very regular query which we get from the online students, that how their queries would be solved. Because for offline student, you can solve your query. I am directly there in front of you, so you can ask me questions. But what about online students? So for them, it would be like we'll form a WhatsApp group, right? For all of the students over here and even the online students as well, we'll have that WhatsApp group. So every day, whenever we finish class, and if online students are watching that video on runtime, then they can ask their doubts straight away on the WhatsApp group. Then next day, I'll see that I'll see that query, and next day I'll solve that query. Then that way it would work. If at all they would see that video after a few days, after a few months, then still they can be in touch with me because they would have number. So this is how it would go. Okay. Now let's start with our overall subject itself, geography. Now, what is the meaning of geography, guys? What does geography mean? No? Study of earth. No, earth, mountain, that's landforms. These are landforms, relief features of the earth's surface. But we have oceans as well, we have atmosphere as well, right? We have human also. Don't you think human is also part of geography? Right? So what does geography mean? Study of environment, then landform is not part of environment. Then?
So for the study of earth, its inhabitants and
study of earth, that's it, description of the earth. Geography means geo and graphos. If you split this word, then geo and graphos. Geo stands for earth and graphos stands for description. So it's a description of the earth. This word geography was coined by Eratosthenes, right? Initially when geography was evolving as a subject, so it was facing a crisis situation. But why there was a crisis initially in the initial phase? Because when geographers started studying, when various geographers started studying this subject, they focused too much on the environmental issues, that how landform, like initially geography was more about description, and that description also was confined only for the landform features which are there over the earth surface. So initially they were like, this is a mountain, now this mountain has this type of soil, then it has these type of trees are present over here, then these types of animals are also present over here. So that description was mostly involved in the geographical studies. But descriptive science was not of much important in that particular time period, because we already had certain university level subjects such as physics, chemistry, bio, which were mostly driven by universal laws. Don't you think so? Then for Newton has given his law that for every action there is equal and opposite reaction. Don't you think this is applicable for all part of the earth? Everywhere that is applicable. For every action there is equal and opposite reaction, that is applicable. So this is these kind of universal laws are there in physics, chemistry and bio as well. So because of this, there was a hue and cry which was there initially, that geography should not be confined only to the descriptive aspect of the subject, right? And that too, most of the study was focused on the environmental aspects as such. So various people, various thinkers and the scientists, they raised question that we already have one subject called as environmental science. So do we need geography? Because we already have one subject, right? Environmental science which studies environment. So do we need geography which would study again environment? So it's a duplication of work. So we don't require geography as such. That's the reason because of which geography could not get that recognition of a subject at the university level. Then slowly and steadily various geographers started studying this. They started understanding this fact that human is also an integral part of the earth surface. Human is also an integral part of the earth surface. See, human, now you would say human is an animal. Then why not other animals? Other animals are considered as part of environmental studies. But then study of human is considered as a part of human geography altogether. Why do we study humans separately? What do you think? Human is different. Human is different. We have brain. And obviously other animals also have brain, but in that case we can analyze with the help of our brain. We can analyze various situations. The way I would react to a particular situation, it's not necessary that all of you would react to that situation in the same way, right? Everybody would have their own choices, their own emotions, their own cognitive abilities. So human behave differently. The choices of human are different. So on entire part of the earth surface where different human are situated at the various part, every human would react in different manner. That's the reason because of which how that human would affect the nature, that would also vary significantly, right? If I don't know how to use coal, so I will not be able to generate energy, but it may happen on the other part of the earth surface somebody has invented how to use coal, then he would be able to exploit that resource for his own development, right? Is it necessary that all of us should know the utility of a coal at the same time? It's not necessary, and that didn't happen. That doesn't happen. It doesn't happen that way. So because of this, study of human also became important part of geographical study, right? Geographical study also, human aspect also became quite important in that. But again, we also have anthropology as a subject, right? We also have anthropology, in which what do we study? In that also we study human. But then if we have anthropology, then in that case we don't require geography, because study of human is also going on over there in the anthropological subject. Then what? Then slowly and steadily, Immanuel Kant, Herodotus and such well-known geographers and historians, they said that geography is not only about study of environment. You should not categorize geography only about study of environment or study of human being as such. Rather, geography is a subject which integrates both the study of environment as well as study of the human. So study of environment as well as study of human is integrated both in the geographical studies. So in that way, geography become a different science altogether. Because in anthropology, we do not integrate human aspect with environmental aspect. In environmental studies, we do not integrate environmental aspect with the human aspect also over there. But geography is the subject which is combination of these two, where we talk about how environment influences man and how man influences environment in other way around that way. So basically it's an integrative study, and that's the reason because of which geography started gaining its overall importance. And then the subject was defined, and then at university level the studies were carried out for various geographical phenomena and all. So this is how geography has evolved. Obviously these all things will study under our perspective in human geography, which is a topic which that is one topic which is there in your syllabus. So we will study all these things under that topic. Now talking about your syllabus. So what does your syllabus have? See, before I tell you about syllabus, let me tell you about this optional paper paper also. All of you are freshers, right? First attempt. So do you know how paper is there for an optional subject? See, for GS we have 20 questions, and this is a straightforward rule over there that we have to attempt all 20 questions, isn't it? That rule is not applicable in optionals. So an optional has a different issue altogether. Here the question 1 to question 8 would be there. Question 1, question 2, 3, 4, then 5. Okay. Question would have 5 sub questions. Question 1 and question 5 would have 5 sub questions, and those 5 sub questions would be compulsory for all of you. So 10 marker question would be there, 5 sub questions, each sub question would have 10 marks, and those questions would be compulsory. You have to attempt them. So question 1 and question 5 would be compulsory. Then you have question 2, 3, 4, 6, 7, 8. Among these 6 questions, you have to attempt any 3. But those 3 questions should be attempted in such a way that either you attempt 2 from here, 1 from here, or 1 from here and 2 from here. So you cannot attempt all 3 from this particular section B. Okay. So you have to attempt 2 over here and 1 over here, that ways. Why I am telling this is because last time one of my very good student, he was very smart and all, he studied geography quite really well, but in mains examination he attempted in a different manner altogether. He attempted question 1 to question 5 straightforward, then 6, 7, 8 he left altogether. So he thought as if 2, 3, 4, so he has attempted 3 questions. So it doesn't work that way. Here you have to attempt 2 questions and then 1 question from here, because they want to check your knowledge both in physical as well as human geography. So if you don't attempt questions over here, that means your human geographical knowledge is that remains unchecked, right? So for that you have to attempt a question over here. Now in each question, 2, 3, 4, 6, 7, 8, in each of these questions you would have 3 sub questions. 3 sub questions would be there, and in those 3 sub questions, first question would be of 20 marks, second 15 marks, and third 15 marks. So 20, 15, 15. This is there in the each question, question 2, 3, 4, 6, 7, 8. Okay. So this is how overall geographical paper is there. Now talking about syllabus of geography. Obviously every optional subject has paper 1 and paper 2. In paper 1 we have 2 parts. Section A, which talks about physical geography, and section B, it is human geography. See, basically paper 1 and paper 2 is such a way that in paper 1 more international aspect is discussed, right? International aspect, that means whatever is happening in the world, landform features, human features, everything is discussed in paper 1, while in paper 2 it's more about Indian geography. So paper 2 is about Indian geography. So under physical geography, what topics do we discuss? First, geomorphology. Geomorphology, what do you think, what would be there in the geomorphology, guys? Landforms, plate tectonics and landform. Basically plate tectonics, if you want to squeeze this topic of geomorphology, it can be categorized into 2 main parts, plate tectonics and landform. Basically it's plate tectonics which results into formation of landform. So first of all you have to understand the dynamics of the plates, and in that continental drift theory, plate tectonic theory, seafloor spreading theory, and all those things would come. And once that happens, what kind of landform forms, and even endogenetic, exogenetic forces would also come into that, and what kind of landform forms and how that landform then results into formation of various surfaces, right? Earth's surface is not flat, right? Earth's surface is made up of various landforms such as mountains, plains and plateaus, various landforms are there. and these landforms eventually affect the climatic features over the Earth's surface as well, right? So how those landforms have evolved, that we study under landform wala topic. So plate tectonic and landforms. Geomorphology will study in quite detail. This geomorphology takes the longest time. An entire physical geography, geomorphology would take longest time. Maybe we would take around 20 to 25 days to finish geomorphology itself. It's quite big, and since last few years, UPSC is asking questions from geomorphology in such a way that students are feeling it quite difficult to attempt. Why? Because earlier more focus used to be given to certain defined topics. Davis-Peng ki theory पूछ ली, then after that plate tectonic theory and all. But now they are going more towards applied part of geomorphology. So we'll study applied part of geomorphology, where you don't need to worry about that. What is applied part of geomorphology, what is static part and all those things, that we'll study under geomorphological studies. Second is oceanography. Obviously we study oceanic features over here. So all oceanic landforms, temperature of the ocean, salinity of the ocean, ocean currents, ocean tides, all those things are covered under this. It's the most easiest, oceanography is the most easiest and most, like, it's the smallest topic of the geography's paper 1. Then we have climatology. This is the topic from where we'll start today, climatology, because it's quite interesting. Obviously, I would not want you to study the most difficult topic from the first lecture itself. So we'll start with the easier one, and climatology is quite interesting as well. So climatology, obviously we study meteorological features, climate over here. Then we also have biogeography. Biogeography, what do you think, what would be there under biogeography? Study of soils. Soils related features mostly we study over here. And along with that, we also study some of the distribution of the plants and animals in the world, how plants and animals over the period of time has got distributed in the world, then gene pool centers of the world, right? That we will study over here. Then next topic is over here, environmental geography. See guys, this topic, environmental geography, is extremely dynamic. It keeps evolving over the period of time. Last time, like yesterday itself, one student called me and he asked me this, environmental geography is continuously evolving in nature. So what we are going to do about that? See, as long as our classes are running, I'll be updating all the environmental features, environmental geographical features regularly. And then that we'll discuss in the class, environmental geographical features. Whatever happens, that I'll discuss. For solving this issue of environmental geography, what I've done is, I'm starting an open forum on YouTube. There would be open lectures, those lectures would be open for all of the students. That would be free of cost, obviously, open for all. In those lectures, generally what I to all my students, what I always tell is, you have to read Yojana, Kurukshetra, Down to Earth and Geography and You. These are the 4 magazines which you need to read being a geography optional student. But my experience says that students don't read that, because it takes a lot of, there is an excuse that it takes a lot of time, then we have to study all the subjects also, then we have to go for classes as well. So you don't get enough time maybe for reading that. So what I have done is, from this month onwards, every month I'll be discussing gist of Yojana, Kurukshetra, Down to Earth, Geography and You, and in that I'll be telling how to integrate these the topics which are discussed in those booklets with geography optional subject, right? That I'll be doing. So with the help of that, what would happen is, if some new things are happening in the environmental studies, then that would also get covered. Recently there was a study regarding Aravallis, that Aravalli is eroding. Then there was hydrometeorological studies of the Himalayas were going on. But these things are not there in the books. Obviously books contain information which is quite redundant in nature, that is quite static. So static aspect will deal, but after that, what to do with the dynamic aspect, the current affairs wala part of geography, what to do with that? So for that I'm going to make those videos. So you don't need to do anything, you just have to watch those videos regularly and make your notes while watching those videos. That is what you have to do. So environmental geography will cover in the class, as well as we'll cover in current affair part of the environmental geography over there as well. Then after that, so this is the physical geography wala part. Now for that, which books to refer? There is one book called as Physical Geography by Savinder Singh. Somebody must have told you this, that different book comes for geomorphology, oceanography, climatology, which was written again by Dr. Savinder Singh. But don't go for those books as of now. Otherwise, it would be too much for you. Those books are huge. As of now, read only Physical Geography by Savinder Singh. That book contains all these topics: geomorphology, oceanography and climatology. Some part of biogeography as well, biogeography and environmental geography. So Physical Geography by Savinder Singh. Again, don't read that book cover to cover. Only read those topics which you feel that it is difficult for you to for you to understand, or if I ask you to read few pages from that book, go through it. Otherwise, don't read it cover by cover. Then there is no, if you do it, then there is no point in joining classes and all those things, right? Because everything will be doing in class, starting from scratch all the way, will cover everything. So, but still, physically, yeah, tell me. New edition, obviously. You have to read the newest edition of this. Then human geography. Under human geography, the first topic is perspective in human geography. This is the most important topic of geographical studies, because here you interlink. Most of the time students skip this topic of perspective in human geography. But trust me, this is the topic which need to be connected with all the topics over here. And how toppers score very high marks. How do somebody score more than 300 marks? It's because those people know how to interlink this topic with the other subjects. Although perspective in human geography itself is small, but that can be interlinked with this paper 1 and paper 2 so much that you would get, here it is the place where you would get edge above all students. So this is a very important topic. We'll study this topic in extreme detail. We'll study in very much detail. It's boring, but still, some student may feel it is boring, but still, it's quite, I'll make it interesting and we'll study it in detail. Perspective in geography, then there is economic geography. After economic geography, we have population. For these books, what books need to be referred? Acha, for perspective in geography, which book, guys? There is one book, Evolution of Geographical Thought by Majid Hussain. Then there is one book also is there which is written by R.D. Dixit, and then there is one more book, Sudipta Adhikari. Now do you need to read all these 3 books? No. Take any one of these books, read it completely, cover by cover. I would suggest this. Books are not big enough, as in you can finish that book within 2 to 3 days. Once we finish perspective in human geography in our class, obviously we would have notes as well, but still I would suggest that go through these books completely. One book at least. One book you have to go through. Evolution of Geographical Thought, you read this book completely, or this. Okay, any one book. They are very small book. You can finish those books within 2 days, right? So these are those books. Economic geography. Again, economic geography is very dynamic in nature and it keeps evolving. So there are various government reports, UN report which keep coming out continuously. For example, in economic geography we have agricultural pattern of the world, right? How agriculture evolves in the world. So what are the problems of agriculture in the African countries, right? How much agriculture, what kind of dietary habits those people have over there in the African region. Then what is the agriculture pattern of the Europe? Why agriculture is more flourished over there? What kind of technology do they use? What kind of soil they have? All these things would be covered under economic geography, right? So this economic geography is continuously evolving subject. If you read your newspaper quite regularly and if you keep analyzing things, then economic geography is easy. But still, if you want to read certain static part of it, then there is one book of K. Siddhartha. Economic geography. But still, I would suggest economic geography can very nicely covered from the internet, right? Internet. There is one more source called as EPG Pathshala. whatever we have discussed over here, geomorphology, oceanography, climatology and all, this is that site, EPG Pathshala, where you would be able to get all these sources. But on this particular site, it is given in very exhaustive manner. But still, you can be selective about your topics, right? So economic geography is covered over there. Population topic, again, this EPG Pathshala, it is covered quite nicely over there. At the same time, RC Chandana's book. It's very nice, the RC Chandana, but again quite bulky. Don't read it cover by cover, only few topics. But still, whatever important topics are there in RC Chandana, we already have those topics in our notes. So you don't need to read this, just for your reference that what are the sources through which we'll be covering and all. So RC Chandana is very good book. Then regional geography, then settlement and models and theories. Regional geography, our class notes are more than enough for regional geography, because again there is one book of RC Chandana for regional geography, but you don't need to go that much. It's quite big book, but regional geography will cover it in our class in quite detail. Settlement and models and theories, that is covered in models in human geography by Majid Hussain. This is that book, Settlement and Models in Human Geography, that is covered by Majid Hussain sir, Models in Human Geography. So these are the sources for the entire paper 1. Okay. Then paper 2, now see guys, paper 2 is all about Indian geography, in which we will be having physical setting, first topic. Now this physical setting is all about the geomorphological features, climatological features of India. So India's peninsular plateau, Himalayan region, coastal plains, we'll be studying all those topics over here. So this topic is amalgamation of geomorphology, oceanography, climatology basically, with Indian perspective, only with Indian perspective. That will be studying under physical setting of paper 2. Then second is resources. Again, this I'll tell you the source for this. Resources, agriculture, then industry, transport, trade and communication, cultural setting, settlement, then political aspect, regional geography of India, and contemporary issues, right? All of these topics of paper 2, all these topics of paper 2 can be covered from internet, and there is one more book called as Khuller, Dr. Khuller. This book is extremely exhaustive. It's about maybe 1000 pages book is there, and in that book, more or less huge, all the topics are covered in quite detail. But again, the data may be redundant, obsolete data would be there, because the book was written by Dr. Dr. Khuller in, let's say, around 5 to 6 years back. New edition must have come, but still data is redundant because data keep evolving. So whatever data which you find, let's say they are talking about maternal mortality rate. So rather than believing in data which is written over there, what you can do is you can go on internet and you can check your data, right, that way. So this is how we are going to study all the topic. These are the sources through which we will be studying. This EPG Pathshala is also quite good, okay. Everything whatever I have written over here, somewhere or other you would get it over there in PDF format. So it's quite exhaustive over there. Let's move. Let's start with our first topic of geography, climatology. In that, the first topic which we will be studying today is fundamentals of geography. Fundamentals of geography. Give the heading fundamentals of geography. When you look at the earth, what is the shape of the earth? Is it geoid? Yes, the shape of the earth is geoid. What is the meaning of geoid? Huh? Egg-like shape. No, 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 no. It's an elliptical shape. Egg has an elliptical shape. It's flattened at the poles and bulged out at the equator. But what is the meaning of geoid? No, no. The meaning of geoid is earth-like. Earth is earth-like because there is no other thing which is similar to earth. So basically the shape of the earth is not spherical, it's not circular, rather it is geoid in shape. Why it is geoid in shape? Because when the earth was forming, initially it was in the gaseous state. Slowly and steadily, because of the cooling process, that gaseous state, the earth which was in the gaseous, see, initially when the earth formed it was in the gaseous state and that gaseous body was continuously rotating along a particular axis. Then slowly and steadily it started condensing. Condensation led to formation of the liquid state, liquid material over the near the earth's surface. But when it was rotating, obviously the centrifugal force was maximum on which part of the earth? What do you understand by centrifugal force? The outward acting force. Outward acting force is called as centrifugal force, right? Just to explain you about centrifugal force, how does that work? See guys, if I have a string with me, let's say only this much string, and that string is tied with a stone, and then I rotate it like this and I throw. How much distance do you think it would go? It would just fall somewhere over here. But I have a bigger string and then I rotate it and then I throw it. It would go farther distance, right? Isn't it? Why? Because the body which is having bigger radius, it has more outward acting force. That means it has more centrifugal force. So on the earth's surface, which particular body is having maximum radius? Equator. Equatorial bodies have the maximum radius, right? Centrifugal force was higher near equator while it was less near polar areas. So all the bodies which were there over the earth's surface near polar region, they also started collecting near the equatorial areas, and earth started becoming more and more flattened at the poles and started bulging out at the equator, because it was rotating and the centrifugal force was maximum at the equator and it was lesser at the pole. That's the reason because of which everything started bulging out at the equatorial part, and over the poles it started flattening. Right. That's the reason because of which the shape of the earth became such that it is geoid in nature, flattened at the poles and bulged out at the equator. The overall shape, this particular shape can be proved with this fact that the total circumference of the earth at the equator is 25,000 miles, while it is lesser, like equator, less polar circumference is less by around 8,000 miles with respect to circumference of the equatorial part. So that basically this is a factual information which suggests that earth is geoid in nature. There are two types of motion which are involved with respect to earth. What are those motion, guys? One is rotation, second is revolution of the earth. What happens because of rotation? What do you think? Day and night takes place because of rotation, while what happens because of revolution? Changes in season. That is the only thing which happens kya? Because of the revolution? No. There are multiple things. Along with the season, there are other things which also takes place. Rotation lead to change in the day and night. So how do you understand the, see, this is the sun over here. just for your understanding, this is the night part. These are the different phases of the earth at different part of the day. Let us suppose a person is standing at this particular position over here, A, and if the earth is moving like this, what do you think? The person which is standing at the position A, he is in which part of the earth? The place where the midday is there, midnight, or dawn or twilight? What do you think? There are four phases, right, in a given day and night. Day, midday, midnight, dawn, that means early part of the day, and then twilight, that means evening time. So what do you think? This person standing over here, it's a midnight over here, right? It's a midnight. The person who is standing over here at this particular point, what do you think? It's dawn over here. Then over here, midday. And over here, it's, yes, dusk, or you can also call it as twilight. Right? So this is what happens because of the rotation of the earth. Then what happens because of the revolution of the earth? Let's understand that. Earth revolves around the sun. And in this revolution, there are three things which are there that takes place, that is change in the length of day and night, change in the length of day and night, right? Second is apparent motion of the sun, and third is change in seasons. Change in length of day and night, apparent motion of the sun, and change in seasons. Now this change in length of day and night, you must have seen this right now in the summer season is going on. When do you think the dusk takes place? At around 7, right? The evening time is there at around 7, 7:15, 7:30, right? But when there is winter season over here, what would be the time at which the dusk would take place? At around 5, 5:30. You would start feeling it's a dark over here. Why that happens? Because during winter the length of day would be smaller or bigger? Small. While the length of day would be bigger in the month of summer. Right? Why does that happen? See, earth is tilted around her axis. How much? Earth's axis is tilted about how much? 23.5 with respect to vertical plane or horizontal plane? Vertical plane. With respect to, if we draw a imaginary horizontal vertical line like this, so Earth's axis is tilted 23.5 with respect to vertical plane, and it is tilted 66.5 with respect to orbital plane. What is orbital plane? That means the horizontal plane. Orbital plane, that means the plane in which Earth revolves around the sun. That is called as orbital plane. That plane in which Earth revolves around the sun is called as an orbital plane. Now, Earth is tilted 23.5 with respect to vertical plane and 66.5 degree with respect to orbital plane. Now let's say this is the sun over here. Okay. Now, sun is throwing its light on the Earth's surface. So obviously, which part of the Earth would get illuminated? Half of the Earth would get illuminated. The part which is facing the sun would get illuminated, right? So what we'll do is, we'll draw half of the Earth over here. This part would be illuminated, while half of the Earth would be under dark. So this is night over here, this is day over here, right? And see guys, this is what? Ye kya hai? Horizontal line? Equator. This is equator of the Earth. Everybody knows the equator, right? Tropic of Cancer, Tropic of Capricorn, everybody knows. As of now, if you don't know Tropic of Cancer, Tropic of Capricorn is okay. let's consider equator. Equator is how much degree? 0 degree. Now see, if we consider this line, then this is the half part of this hemisphere, and the remaining, this is half part of the hemisphere. The light is falling on the earth. You can see yourself. If apparent motion of the sun, that means the sun is towards the northern hemisphere. See, right now earth is tilted like this, that means northern hemisphere is facing the sun right now. So in that case, how much part is under day? Is it more than 50%? See, is it more than 50% part which is under daylight right now? While this much part is under night. This much part is under night. Are you getting this? No? Okay. This is the earth. This is the axis of the earth, right? This is the equator. Can you see these 4 parts now? Are these 4 parts equally divided? Right? Now sun's light is, I'll remove this as of now. Now see, sun's light is falling on the earth's surface. Right now, sun is towards which part? Northern part or southern part? So it's towards northern part. Basically, earth revolves around the sun. So when earth axis is like this, see this one, earth's axis is like this, it's tilted. So when the sun would be over here, northern hemisphere is facing the sun right now. And when the earth would go over here, then southern hemisphere would be facing the sun. So whichever hemisphere is facing the sun, on that particular part you would have summer, and on the other hemisphere you would have winter, that ways. So right now sun is there in the northern hemisphere. Now what we'll do is, we'll divide earth into half part, because on the half part we'll have day, half part will have night. So this is the vertical axis which we'll draw it over here, right? So what you need to do is, you just have to shade that particular part where the day is there, while the other part will be under night, or you can shade the night wala part. So see, this part is under which, what, day or night? Day, while this part is under night. Now see, this is which hemisphere? Northern hemisphere, and the remaining is southern hemisphere. Now in the northern hemisphere, can you see this? More than 50% part is under day. See, right? While less than 50% part is under night. Let us suppose, see, earth, it doesn't matter on which part of the earth are you, but along with the earth, even you also take 24 hours to complete one rotation, right? If you are standing over here, so earth is revolving around, rotating along with the earth, you also rotate, and then you also take 24 hours to complete one rotation. That means you would pass through from all the night and day part of the earth's surface, right, in a given day. In a single day, within 24 hours, you would pass from all these night and day part, right? That's the reason because of which you would be able to see certain part of the day which is under light, and certain part of the day under dark. So here let's suppose some person is standing over here, A, and then earth rotates. That A would also rotate along with the earth. Don't you think A would remain for maximum part of that particular day, he would remain under light or under night, under dark? If he is in the northern hemisphere, for a maximum part he would remain under light, while for the lesser part he would remain under. How many of you are not getting this? Understood, everyone? So this particular person standing over here, for that matter, all people who are there in the northern hemisphere, they would remain, for the maximum part they would remain under light, while for the lesser part they would remain under dark. That's the reason because of which the daylight would be longer for the people who are there in the northern hemisphere, and night time would be shorter. So that's the reason because of which during summer season you have bigger day and shorter nights, while in the winter you have. So for people who are standing over here, let's say in southern hemisphere, for them they would remain for for longer duration, they would remain under dark, while for short duration they would remain under light. So they would have shorter day and shorter light day, and then longer nights, that ways. So change in length of day and night, that takes place because of the revolution of the earth, right? At the same time, apparent motion of the sun. What does that mean, apparent motion of the sun? Actually, I should have told you about apparent motion of the sun first. See, this is what apparent motion of the sun is. Earth is revolving around the sun and there is a tilted axis over here, right? Now we divide earth into two parts, northern hemisphere and southern hemisphere. Now along with equator, there are again two important latitudes which we have over the earth's surface. What is the name of those latitudes? Tropic of Cancer and Tropic of Capricorn. What is the degree of Tropic of Cancer and Capricorn, guys? 23.5 degree in the north and 23.5 degree in the south. This is the angle, right? Why do you think it's 23.5 only? Why not 23 or why not 24? Why only 23.5? Tilt of the axis. Basically, rather than saying tilt of the axis, what we can say is tilt of the sun is maximum up to 23.5 in the northern hemisphere and 23.5 degree in the southern hemisphere. How sun tilts? This way. This axis of the earth is like this. Now this sun is over here. Which part of the earth is facing the sun right now? Northern hemisphere or southern hemisphere? All of you are getting right. Which part of the earth is facing the sun? Northern hemisphere. Right now northern hemisphere is facing the sun. That means sunlight is falling directly on the northern hemisphere while it is falling obliquely on the southern hemisphere. So northern hemisphere is facing the sun. Now when this earth, that means it is on the northern hemisphere. Now when the earth goes over here like this rotation, now sun is directly overhead on which part of the earth right now? On equator. Are you getting this, everyone? Because sunlight is, sunlight is right now. When the sun was over here, and the earth was over here, the light was falling at this particular part. That means on the north of equator. Earth goes over here. Now that light is falling on the equator, right? Now when the earth goes over here, the sunlight would be falling in the southern hemisphere. And when the earth comes over here, the sunlight is directly falling on equator. That means, what do you see? Northern hemisphere, equator, southern hemisphere, equator. Northern hemisphere, equator, southern hemisphere, equator. Are you getting this? So basically it feels as if the sun is going from northern hemisphere to equator to southern hemisphere. Again from southern hemisphere to equator to northern hemisphere. It feels, but do you think sun is actually moving? Sun is not moving. Who is moving? We are moving. We are moving around the sun. That's the reason because of which it's as if this. We are sitting in a train and we are going forward. So we feel as if the trees are going backward. But do you think trees are going back? No, trees are static over there. Trees are standing in their own location. But as we go forward, we feel as if trees are going back. Exactly in the same way, just because we are revolving around the sun, we feel as if sun is going from northern to southern hemisphere. This is called as apparent motion of the sun. That is the reason because of which that name apparent is given. Okay. Now see, this is apparent motion of the sun. But the point is, up to how much distance the sun would go? Up to how much distance the sun would go? Just because the tilt of the earth is 23.5 degree with respect to its axis, vertical axis, isn't it? Just now you told me actually. It's with respect to vertical axis, it's 23.5 degree, right? The earth's axis tilt, this tilt of the earth. Now see what happens. Let's suppose this angle become like this. I increase this angle, okay? I increase this angle. If it becomes like this, then sunlight would directly fall in. Sunlight would be directly falling on which part? On the poles, right? Now we'll again make it normal. Now sunlight would be falling on which part? Somewhere at around 23.5 degree. So maximum tilt of the sun's rays, sunlight, that would be up to 23.5 degree. Why? Because Earth's angle is 23.5 degree with respect to its vertical axis. So that light is falling 23.5 degree north. Then it goes like this on equator, 0 degree. Again it goes over here, 23.5 degree south. Again it goes over here, equator, 23.5 degree. So 23.5 degree north, equator, 23.5 degree south, equator, 23.5 degree north. This is the motion of the sun, apparent motion of the sun for the entire year. That is the reason because of which, other than equatorial latitude, we also divide another latitude, another like two important latitudes, which is called as Tropic of Cancer and Tropic of Capricorn. So we divide this into, this is Tropic of Cancer and Tropic of Capricorn. Everybody understood this? Apparent motion of the sun and all. So apparent motion of the sun is Tropic of Cancer to Tropic of Capricorn. Now because of this apparent motion of the sun, change in length of day and night takes place, and because of this apparent motion of the sun, even the this season also changes continuously. But how does season changes? Because of the apparent motion of the sun. See guys, when I say sun is over here and the light is directly falling on the northern hemisphere at the Tropic of Cancer, right? So at that point of time, southern hemisphere is away from the sun. See, southern hemisphere, on the, if the light is directly falling on the northern hemisphere, how do you think the light would be falling on the southern hemisphere? Inclined, oblique, right? So like this. I will draw this northern hemisphere and southern hemisphere. Right now, sun is over here. So sun's light is falling like this. So this, let's say I name this as A. Then there is one light of the sun this is called as B. What do you think, size of A is bigger or size of B? B is bigger than A, right? But the light, the amount of light which is falling on both the region, that amount of light is same kya? Yes, amount of light is same. Here, whatever amount of light is falling, that amount of light on the B is same. So what exactly happens over here? Same amount of light gets distributed in the bigger area over here, while it gets concentrated in the smaller area. So you tell me, if the light would get concentrated in smaller areas, so hitting effect would increase or decrease? Hitting effect would increase. If the light gets concentrated in the small, when you were young, you used to play with that glass convex mirror, concave mirror, that magnifying glass. If you concentrate that sunlight on a particular page, then that page start burning. You must have performed that experiment when you were young, right? So when light gets concentrated at a particular part, the heating effect increases. So here heating effect would be more, while over here heating effect would be less. That's the reason because of which in part B, that means in the southern hemisphere right now we'll have winter, while in the northern hemisphere we'll have summer. But again, overall intensity of the summer would not be equal at all places of northern hemisphere, or overall intensity of winter would not be equal at all places of the southern hemisphere. How that intensity of summer and winter varies? As I said, the apparent motion of the sun goes from which part to which part, guys? From Tropic of Capricorn to Tropic of Cancer, Tropic of Cancer to Tropic of Capricorn, and again back. So at the most, sun can go, the apparent motion of the sun can go up to which part? 23.5 degree north and 23.5 degree south. Beyond that, sun would not be able to go. That means, see, what does that mean is, if the people live between Tropic of Cancer and Tropic of Capricorn, in a given part of the year, they would be able to claim that sun comes directly overhead above them, right? Let's suppose this is Tropic of Cancer, Tropic of Capricorn. Some person lies in this particular area over here, right? And sun moves. don't you think there would be a particular part of the year where the sun would come directly above this particular person? Sun would come directly above, right? But if some person is living over here in some part of Canada maybe, do you think he would be able to claim because for him sun at the most comes up to Tropic of Cancer. So although he is there in the Canada, sun would not be able to come directly overhead above him, rather he would be able to see sun like this. So for him sun would be over there like that, sun would not be directly overhead. So sunlight would come in an oblique manner like this, sunlight would come in an oblique manner towards the people who are there in the Canada. So obviously again heat would get distributed and overall heating effect would reduce and there would be more coldness over there. So even in the summer season also the people in Canada, they would feel cold, right? So even after having summer they have more cold over there, and winter are quite harsh in Canada. The winters are quite harsh in Russia because see, sun is over here, then sun goes over here. Now when the sunlight is falling like this, see, Canada is over here. The light though would not be able to reach all the way up to Canada itself. So people in Canada would always have devoid of light. They would always have lesser light. See, the kind of bright daylight which you see in India, right? In foreign countries, if you go in the northern countries towards Canada maybe, you will not be able to see such bright sunshine over there. It is not such bright over there, right? So why? Because light mostly falls obliquely. The evening time is longer in Canada. The evening time is bigger in Russia as well. Why? Because most of the time light is falling obliquely. So overall intensity of the light is quite less. So we have very quite intense daylight over here. Right now if you go outside, it's quite intense daylight. That kind of intense daylight is not present over there. Why? Because light is concentrated in our part. In our region, light gets concentrated. Over there, light doesn't get concentrated. Rather, it gets dispersed in bigger area. Right? So this is how overall intensity of the light even in the summer season in the northern hemisphere, that varies at the various latitudinal regions. So this is the impact of the rotation and revolution over the Earth's surface. Then after that, okay, before that I'll also tell you one Milankovitch cycle. Milankovitch cycle. What is Milankovitch cycle? There was one geographer whose name was Milankovitch. In his studies, he explained that the movement of the earth around the sun, the revolution of the earth around the sun, that also results into change in the heating pattern of the earth's surface, change in the climatic patterns of the earth's surface. So if somebody would say that whether revolution or the axial tilt of the earth, does that have anything to do with the climatic change over the earth's surface over the period of time? So in shorter run, if you would say that within a year it would change the climatic pattern of the earth's surface, so no. But over the period of time, let's say after 50,000 years or within 1 lakh years, would it change some climatic pattern? Yes, that has some role to play in the change in climatic pattern. But how? He said in this Milankovitch cycle, he said 3 factors are very important in understanding about the change in climatic system. He said 3 factors are very important in overall Earth's rotation and revolution, which changes climatic pattern. So what are those 3 factors? First is eccentricity. Second is axial tilt. And third is precision. So what is eccentricity? You must be knowing that Earth revolves around the sun, and what is the shape of that orbit in which Earth revolves around the sun, guys? Elliptical orbit, right? That elliptical orbit is, this is the sun over here. And it's more like an egg, isn't it? So if Earth is over here, what do we call this? Apogee, perigee, perihelion, aphelion, क्या बोलते हैं इसको? Perihelion, what? The shortest or longest? This is called as, if the position of the earth is over here, the shortest distance of the earth with respect to sun, it's called as perihelion. While the longest distance of the earth with respect to sun is called as aphelion. Perihelion and aphelion, right? Now this Milankovitch said that this shape of revolution of the earth with respect to sun, that never remains constant, rather that keep changing. That keep changing from this elliptical orbit to spherical, like circular orbit altogether. So, and that changes within how many years? In how much years of cycle does it change? 1 lakh years. Within 1 lakh years, the earth's elliptical orbit becomes more circular. Then after within 1 lakh, again after 1 lakh year, it would become more and more elliptical. Then again it would become circular and it would become elliptical. So this change in the shape of the orbital rotation of the earth with respect to sun, it is called as eccentricity. This is called as eccentricity. When this change takes place, so obviously the size of aphelion would become smaller, the size of perihelion would become longer. So because of this, the distance of the earth with respect to sun, that also changes, and overall hitting effect on the earth, that also changes, because longer the earth would go from the sun, the hitting effect would reduce. If it come closer, hitting effect would increase. So if this particular shape of rotation of the earth with respect to sun, that changes, along with that the hitting pattern on the earth would also change. This is called as eccentricity. Okay. The next is axial tilt. You just now told me that what is the axial tilt of the earth with respect to that vertical axis? 23.5, but that is not 23.5 all the time. Rather, it changes from 22.1 to 24.5 within the gap of 41,000 years. Within 41,000 years, that changes from 22.1 to 24.5. So it keeps changing. Then why do we take 23.5? Basically we take average. So on an average we take it 23.5, but otherwise it keeps changing from 22.1 to 24.5. So it keeps changing like this. If this is the 23.5 axis, so it keeps changing like this, right? So because of this also, see, if this axis changes, it becomes, let's say it becomes 24.5, that means if the angle changes, if it becomes more, that means northern hemisphere would come more closer, right? The more light would be falling on the northern hemisphere, isn't it? So hitting effect would be more or less? It would be more. That means if the angle of the axial tilt that increases, the hitting effect would increase. If the angle decreases, hitting effect would reduce. 22.1 to 24.5. This is the change in axial tilt of the earth, and this basically 22.1 to 24.5, that happens within the gap of 41,000 years, right? So on an average we take it 23.5. So this continuous change in the axis of the earth, that also changes the hitting pattern on the various latitudes of the earth's surface. This is called as axial tilt. And then finally we have precision. What is precision? So he said that this rotation of the earth never remains static, rather earth wobbles like a top. Have you seen, when you were young you used to play with this top? Have you ever seen this one, this top? There are different names, regional names must be there, but that top is like that. It's like this. Then you attach one string to it and then you throw it. You must You must have played with that, right? After a particular rotation, it starts revolving like this, right? This is called as wobbling. It wobbles at the place where it is rotating, right? Exactly in the same way, even while rotating itself, Earth starts wobbling like this. Earth wobbles. So because of this wobbling of the Earth, because of this wobbling of the Earth, that also changes the heating pattern of the Earth's surface, and this is called as Milankovitch cycle. So Milankovitch cycle said there are 3 factors responsible for the overall change in the heating pattern and the climatic change over the Earth's surface, and this happens because of this eccentricity, axial tilt and precision, right? So basically Milankovitch was talking about the climatic change, the climate change, why climate change takes place. So he explained it in this particular way. Okay. So right now we have discussed about the rotation, revolution and overall this Milankovitch cycle and all. Now let's move towards the next one, various latitudes and longitudes. When we take a map and in that we see various latitudes and longitudes, we see that latitudes are from 0 degree to all the way up to 90 degree, right? 0 degree to 90 degree. Longitudes also are from 0 degree all the way up to 180 degree, isn't it? How do they define this latitude from 0 to 180 degree, or longitude 0 to 180 degree or 0 to 90 degree latitudes and all? How do they define that? So basically they define it like this. Latitudes are the horizontal, imaginary horizontal lines which are there over the Earth's surface, while the longitudes are imaginary vertical lines. So let's suppose we divide Earth, we cut the Earth into 2 vertical halves. So we cut down, we take one half, in that let's take, this is the center of the Earth. There is an imaginary line we draw over here. Now whatever angle which a given line would make with respect to this imaginary line, that would be the angle of latitude. This line is making an angle of how much degree with the same line? 0. So obviously drawing from here, this is the equator which is 0 degree. Let's suppose this line makes an angle of 5 degree. So from here we will draw another latitude which is 5 degree, but as it lies in the northern part, it is 5 degree north. So this is how we keep defining it. This line that makes an angle of 90 degree. So obviously poles are 90 degree north and then 90 degree south, that ways. So this is how we define various latitudes. What about longitudes? How do we define longitudes? Again, if we have taken that vertical cut, then you have to take the horizontal cut. But in horizontal cut there is one problem. You don't have the central line. Do we have central line in that? Pay attention over here. Central line. Do we have central line in with respect to longitude? See, for latitude, so we obviously have one central line called as equator. It's very obvious. Equator is a central line from northern and southern poles. But with respect to longitude, do we have central line? Oh, we don't have central line in that. So you have to assume one central line. So for that we have assumed GMT, Greenwich Mean Time. So that Greenwich Mean Time is the line which we have assumed that it's a central line, and from there we have defined various latitudes. It's a 0 degree longitude, and on the east of it, so if we observe, let's say we are sitting on a terrace and we are looking down. So the earth is, let's say earth is rotating from west to east. So what do we see over here? We'll be able to see the central part, right, the Arctic region, and from there the lines are going away. So we draw it over here. This is the earth, the central part, the lines are going away. So consider any particular line, and from that particular line whatever angle it makes, let's suppose this makes an angle of 10 degree and it lies on the eastern part, so it would be 10 degree east. If it lies 10 degree western part, so it would be 10 degree west. So this is how they define various angles on the latitudes and longitudes. Now what is the use of latitude and longitude, guys? What is the use of latitude? First of all, let me tell me about latitudes. What is the use of latitudes? Latitude helps us defining various climatic zones. Just now I have explained you this, right? क्या बोला मैंने? This is the equatorial part. Just now we have defined two important other than equator, we have defined two important latitudes. What is the name of the what were the name of those latitudes? Tropic of Cancer and Tropic of Capricorn. So 23.5 degree north, 23.5 degree south. So this is Tropic of Cancer, Tropic of Capricorn. Sun, apparent motion of the sun cannot go beyond Tropic of Cancer and Tropic of Capricorn. That means maximum heating effect is concentrated between Tropic of Cancer and Capricorn, right? That particular area is called as, no, that is not called as equator. That is called as tropical region. This is a tropical region. Okay. Then after that, again we have two important latitudes, 66.5 degree north, 66.5 degree south. Why do we need to draw these latitudes? These are called as Arctic Circle and Antarctic Circle. This is called as Arctic Circle, this is called as Antarctic Circle. What do you think? What would be the meaning of this? Basically, these latitudes are the one after which permanent snow starts. Permanent snow, that means doesn't matter whether it is day or light, snow would remain for sure. Arctic region, basically Arctic and Antarctic region starts. So from here onwards, Arctic region and Antarctic region. So what is this area? What do we call this? No subtropical, temperate region. This is also called as temperate region. See, subtropical lies in this particular part. The region which is nearer to Tropic of Cancer, we call it as subtropical areas, right? So it lies somewhere in the tropical only, towards end part of tropical region. So tropical region is also called as torrid region. But torrid word we do not use quite frequently. Rather, tropical region we use quite frequently. And then after temperate region, what do we use? What is the remaining part? Polar region. Or it is also called as frigid zone. Frigid. Torrid zone, temperate zone and frigid zone. Okay. So these climatic zones are defined. These areas, these heating zones are defined with the help of latitude. Latitude are again used for defining what? What do you think? For defining date, time. Do we use latitude kya? No, we don't use latitude for defining date and time and all those things. For that we use longitude. Then what is the use of latitude? Latitude also helps us finding out the location of a particular place, isn't it? So location, we can find out location with the help of latitude. Now, latitudes are parallel to themselves and latitudes are parallel to each other as well. That is the reason because of which latitudes are also called as parallels of latitude, because all latitudes are parallel to themselves and to other latitudes as well. So all latitudes are parallel. But can we say the same thing about longitude as well? No, longitudes are not parallel. Rather, longitudes are converging at a particular point. So if we say over here the longitudes would be like this, so longitudes are converging. So longitudes are not parallel, they are not called as parallels of longitude. So what is the function of longitude? Why do we use longitude, guys? Longitudes are used for finding out date and time. Chalo then, we will find out date and time with respect to longitudes. First of all, what we will do is, we will find out date and then we will move towards time because it is easier then for you. Then there is a country over here, United Kingdom, right, England. The line which passes from there is called as GMT. Why Greenwich Mean Time passes only from England? Because when these lines were defined at that particular point of time, UK was superpower and all those things. So obviously, whichever would be the superpower, they would want that 0 degree line to go from there. And main observation which was done with respect to movement of the earth was done through Greenwich Observatory, which is situated in London. So that 0 degree longitude passes from that Greenwich Observatory. So it is 0 degree over here. Okay, so this is 0 degree longitude. There is one more line which is important, longitudinal line, which is situated exactly opposite part of the GMT line. What is the name of that line? International date line. International date line. But the international date line is zigzag. It's like this. International date line is zigzag. Why? What is the name? Why international date line is zigzag in nature? To avoid land masses, because basically with the help of international date line, you define various dates. You define dates with the help of that, right? But if in any, let's suppose it passes from any particular country, if international date line passes from any particular country, so half of that country would have different date and half of the country would have different date altogether. So it would become cumbersome for the people to manage those things, right? That's the reason because of which when this international date line was defined, it was given, the people were given option. People were, that country was given option that whether you want to lie towards US time zone or towards New Zealand's time zone. So whichever they have chosen, so that country lies on that particular part. Okay, so that's the reason because of which international date line is zigzag. So international date line passes only from water body. It doesn't pass from any land region. Now, as we have seen, Earth moves from which part to where, like from which direction to which direction? It moves from west to east. Earth rotates from west to east, right? So apparently sun will move from where to where? That's the reason because of which sun rises in the east and sets in the west, isn't it? But just now you said that Earth, the sun moves from Tropic of Cancer to Tropic of Capricorn. Now on one hand you are saying that sun is moving from Tropic of Cancer to Tropic of Capricorn, and now you are saying that sun moves from east to west. What, as in, what is happening exactly? Do we have two suns then? Did you understand the question actually? Here when we say that Earth is moving from west to east, when it moves from west to east, obviously apparently we will feel as if sun is going from east to west. And then like few minutes back we have also discussed that sun is moving from north to south, Tropic of Cancer to Tropic of Capricorn. How is it possible? How can there be two motion of sun? One is with respect to revolution, one is with respect to rotation, one is with respect to revolution. When the Earth is moving in a circular orbit around the sun, at that point of time sun goes from Tropic of Cancer to Tropic of Capricorn. Apparent motion of the sun would be like that. So that motion of the sun will be with respect to year, a given year. In a given year sun would move from Tropic of Cancer to Tropic of Capricorn. But for a given day, for a single day, sun would move from east, it would rise in the east, it would set in the west. Why? Because Earth is moving from west to east. So even if sun is static over here, so sun's light would fall and that light would apparently move from east to west. That means sun will move from east to west. So apparently let's suppose I am standing over here and I am moving like this and sun is static over here. So for me it would feel as if sun is going like this. The same logic of the train, in which train is moving forward and we feel as if the trees are going back. Are you getting this? So sun moves from east to west, sun rises in the east and sets in the west. Obviously, can we define a particular location where the sun rises first? That though there, but is there, do you think Japan is the location where the sun rises? It's a circular earth. So it can be any location basically, you can take any location from where the sun would rise. but we have taken Japan. We have taken Japan. Obviously, we had to consider one location, so we have taken Japan. So Japan is also called as the land of rising sun. You must have heard this name, land of rising sun, right? So what we'll do is, Japan is situated over here. This is Japan. What we'll do is, let's suppose sun is present over here. Chalo, sun. Now we are defining date, okay? We are defining date over here. Sun is present over here. So wherever the sun is, what would be the time? Because sun has risen just now. So sun is present over there as of now. So what should be the time? The day should have started now. The day should start, right? So what should be the time? 0. That means 12 am. It should be 12 am. So wherever the sun is, remember this. Wherever the sun is, the time would be 12 am because the day has started now, because the sun comes over there. So it's 12 am. What would be the date? So consider any particular day. Let's suppose today is date 21st June. Okay. So 21st June is there. So wherever the sun is, the date is 21st June and the time is 12 am. Now what is the total circumference of the earth? It's 360 degree. It's a circular body, so it should have 360 degree circumference, right? The total angle of circumference should be 360 degree. Pay attention properly. It's 360 degree total angle of circumference. Total Now, how much time does Earth takes to complete one rotation? 24 hours. 4 minutes. 24 hours. Earth completes one rotation in 24 hours. That means this 360 degree is covered in how many? That means apparent, if the sun is, Earth is moving from west to east in 24 hours, so even the sun is moving from east to west within 24 hours. So sun rises in the east and sets in the west, and all this feature. That means with this, in India, let's suppose in Delhi, sun will rise in the east, would set in the west, and again it would come in the east. How much time would it take? 24 hours, right? That means for the sun also to move from east to west and again come back to east, it will take 24 hours. That means 360 divided by 24. Kitna? 15. That means if within 24 hours it covers 360 degree, so in 1 hour it would cover how much degree? 15 degree. So in 1 hour sun would cover 15 degree. Are you getting this, everyone? Now sun goes over here. How much? 15 degree. Sun goes 15 degree westward. What should be the time over here? 12 am. Because I said wherever the sun is, the time will be 12 am. What is the date? (21st June). What would be the time over here, guys? In Japan now? Because 1 am, because now the sun has passed 15 degrees, so 1 hour has been crossed. So 12 am tha pehle, now it would be 1 am. But the date remains same, 21st June, because the day has just started. Now the sun would go again 15 degree westward. What is the time over here? 12 am. What is the date? 21st June. What is the time over here? 1. What is the time over here? 2. Everybody understood this? 15, 15, 15, 15, 15, 15, 15. It would go all the way. When I draw this diagram, I hope you understand that Alaska, this is Alaska. Alaska is facing Russian part. It's circular body, right? So it's facing Russian part. So basically that Alaska is over here. Like this. So when the sun comes over here, that means over here. When the sun comes over here, it's 345 degree. Let's say it's 345 degree now. Right? So when the 345 degrees, so the sun comes over here, what would be the time and what would be the date? Time is? No 11, 12. 12. It's 12 am. What is the date? 21st June. Now sun crosses and it comes over here, so 360 degree rotation is complete. So the sun would come over here. What should be the time? It's 12 a.m. But what would be the date? 22nd June. What would be the time over here in US? 1 a.m. What was the date? 21st June. That means even after locating very nearby to each other, Japan and US, they are so close that it would take more time for us to go from Srinagar to Kanyakumari. So they would reach first with others. They are very close. They are very closely situated with respect to each other. So even after locating such close distance, but still they have different dates altogether. Whereas in Japan we have 22nd June, in US we have 21st June. And what do we understand from this? As you go east of international date line, you gain day or you lose a day? You gain a day, because you are going 1 day back, 21st June, right? If you go from Japan to US, you go 1 day back. That means you become 1 day younger. Apparently, you don't become 1 day younger as such, but still apparently you feel as you gain a day. But as you go from US to Japan, you lose a day, right? So this is how date can be calculated with the help of international date line. Now, how GMT is helpful? Now, GMT is used for calculating time. How do we calculate that? See, take any particular latitude over here. So what I will take is this particular latitude. Let's suppose sun is present at this particular latitude. What is the time? Wherever the sun is, the time would be? Okay. Now keep sun in this particular region only. What would the time over here in this latitude? 11. What was the time over here? 1. That means if this is the reference line, with respect to this reference line, if you go east of it, you have to add time or you have to subtract time? You have to add. If you go west of it, you have to subtract the time. But this reference line can be anything, right? So what we have done is, we have taken that reference line as GMT. So GMT is 0 degree. If you go east of GMT, you have to add time. If you go west of GMT, you have to subtract time. This is how it goes in this GMT calculation, overall GMT calculation. So the time can be calculated with the help of GMT, and the date can be calculated with the help of international date line. So now we have Indian time zone as well. So that is called as, what do we call it? IST, Indian Standard Time. IST. And that IST is how much? 82.5 degree. That IST is 82.5 degree. So what do you think it would be, how much ahead of the United Kingdom's time zone? 5 hours 30 minutes. 15 degrees is equal to 1 hour, right? So 82.5 degree is equal to 5 hours 30 minutes. So we are 5 hours 30 minutes ahead of the GMT timeline, because whatever time is defined in the world, that is defined with the help of with reference to GMT time zone. So GMT time zone के हिसाब से we are 5 hours 30 minutes ahead. ठीक है? Everybody understood this? This one? One? No, sun was over here, 12 a.m. Then sun comes over here, so 1 hour is passed. That means 12 a.m. So forward 1 a.m. Sun would be going over here. See, observe. Let's suppose what we'll do is, sun is over here. What is the time? No, not noon. We are not in noon right now. No. See, whenever the sun goes, wherever the sun would go, the day would start first, right? Sun would rise, so first of all, day would start, na? You must be confusing with this, that in the midnight we don't have sun at all. So how can you say that sun comes over here? So basically when you have midnight 12, at that point of time sun is beyond the horizon for you. For us, sun is beyond the horizon, but still the day has started. Sun is there, but sun is beyond the horizon. So that's the reason because of which light would not be able to come. Within 6 hours, within that 6 hours, then sun would be able to come. After 12 am, within 6 hours, sun's light would be able to come to us. So day starts. But actually day starts at what time? 12 am. So we always consider that at 12 am, sun, wherever the sun is, the day has started. Wherever the sun would go, the day has started. But problem is, the sun remains beyond the horizon. So it takes 6 hours for the sunlight to come. Beyond the horizon, that means you must have seen sometime that when there is a dusk, so sun goes beyond something, beyond a particular land. Have you ever observed the dusk or the dawn properly? So sun comes from behind the mountain, or it comes from some landmass somewhere. So basically that is because earth is spherical, so your eyesight would not be able to see. If you are standing over here, your eyesight would be like this. So you will not be able to see something which is present over here. So sun is present over here right now. So sun's light would not be able to come. So the sunlight would not be able to come, it would remain dark. And it would take 6 hours for that darkness to get removed and the daylight to come. But for our convenience, what we do is, for defining date, for convenience, what we do is, wherever the sun is, the day starts. And that day starts at 12 am. So don't get confused over here that there is a night and then there is no sun at all, then how can we consider that and all those things? Forget about that. As of now, what we need to consider is, wherever the sun is, the day starts. So day starts over here, so it's 12 am. Okay? The day starts over here, so it's 12 am, wherever sun is, 12 am. Now when the sun moves over here, when the sun would come over here, the time would be 12 am. But 1 hour has passed over here, so it would be 1 am. And 11 pm over here already. That means this is how we consider. So don't get trapped into that. As of now, only for our convenience, consider this way. Sun, जहाँ पर भी sun होगा वहाँ पे it's 12 am. ठीक है? Now we have understood how to define date and how to define time, and IST also we have considered. Any doubt in this? Any problem in understanding? This was very fundamental, very basic part of the our overall geographies. तो उस केस में एक तो डॉन होगा या फिर ट्वाइलाइट होगा. अब जब इवनिंग का टाइम होता है ना हमारे यहाँ पे इवनिंग, तब हम एक्चुअली उस वक्त उस एरिया में होते हैं जहाँ पे यहाँ पे दिन है और यहाँ पे रात है. बट हमारी एग्जिस्टेंस इतनी छोटी है, वी आर सो स्मॉल दैट विल नॉट बी एबल टू रिकॉग्नाइज दिस कि भाई यहाँ पे दिन और यहाँ पे रात है वगैरह, कि वी आर वेरी स्मॉल. इफ लेट्स से यू हैव दैट सुपर पावर कि जिससे आप बहुत बड़े हो जाओ, बहुत बड़े, तब आपकी आंखें देख पाएगी कि ओके ओवर हियर देयर इज डे एंड ओवर हियर देयर इज नाइट. जस्ट बिकॉज वी आर वेरी स्मॉल विल नॉट बी एबल टू सी दैट, है ना. तो व्हाट यू आर सेइंग इज, व्हाट हैपेंस इफ देयर इज डे ओवर हियर एंड नाइट ओवर हियर, तो यू आर स्टैंडिंग इन डस्क or you are standing in dawn. Anything else? Take a break. We'll start within 5 minutes we'll start this class again and start with the next topic. NCERTs are important, extremely important, as in you have to read 6 to 12th NCERTs. That's very important for all of you. 6 to 10th NCERTs, go through it. Like you can underline the topics which are there under 6 to 10th NCERTs properly, as in while reading you can underline important topics. But 11th and 12th NCERTs, and preferably old NCERTs, 6 to 12th old NCERTs. In that, in 11th and 12th NCERT you have 4 of them, 2 for physical geography of India and world. In the 11th and 12th you have human geography, extremely important. Make notes of all NCERTs from 11th to 12th. So all those 4 NCERT you have to make notes of them. Okay, so make sure that you make notes of 11th and 12th NCERT, because most of the time this also happens that we have to refer our NCERTs as well throughout our course. So NCERTs are extremely important, go through it. Again, there is one more book, GC Leong, but as in obviously for reading purpose, read GC Leong once or twice. Then after that, once you see, initially right now even if you have a geography is the optional, but you are as good as new student who doesn't have any information regarding geography. You are completely like that particular person. So you have to follow the same approach like the new student, in which you have to read NCERT and then you have to read GC Leong. Once you become familiar with various aspects of geography, right, then again you don't need to read those books later, in later part. That means let's say after a year or 2, once you become master, like if you read everything regarding geography and your concepts are clear, then you don't need to read GC Leong maybe. But as of now, being a fresher, you have to read those books, GC Leong and NCERTs, right? There is a misconception ki I have a geography option, so I don't need to read those basic books and all. But obviously everybody starts from basic, so you have to read all basic books first of all. Let's start with the next topic. Structure of the atmosphere, structure and composition of the atmosphere. Whatever we are discussing in the class, guys, whatever happens from Monday to Friday, there will be a test which will be conducting on Saturday. That test would not be very long test as such. It would contain 4 to 5 questions. On every Saturday, you would have a test that would contain 4 to 5 questions. You have to attempt that paper. And don't say that I'm not feeling well and my stomach is aching and all. You have to attempt that paper, and I'll check it personally, and then we'll have discussion. So I'll give you your copy. Once you get your copy evaluated, come to me, see how much improvement you could have made, and next in the next test try to implement those things. Saturday, the time will let you know. Or regarding availability of the classes, the time would be will tell you the time. But test would be there. It may happen that at times I have to cover more topics, so in that case I'll conduct class and there will not be a test. If at all I conduct class on Saturday, then there would not be a test. But otherwise mostly on every Saturday we'll conduct a test. Okay? And whatever we have discussed from Monday to Friday, that would be there in that particular test. So that will follow. Let's start with structure and composition of the atmosphere. Now before we understand, see, today we have a kind of atmosphere over here which consists of the various particulate matter, gases, water vapor, and atmosphere is made up of these things only, right? Particulate matter, water vapor and various important gases. This is the main ingredient of our atmosphere. But how our atmosphere must have evolved? What do you think? How our atmosphere has evolved? How it has taken, what are the main factors which has led to evolution of the atmosphere which we see today? Condensation, evaporation. Okay. Various gases. We'll see. Condensation is one process which was there. We'll see what was the reason for, because of which our current atmosphere has formed. Before volcano, that is one of the factor. Volcanic eruption is one of the factor, right? That led to degassing and all. Before the current atmosphere which is present right now, we had earlier atmosphere which is called as primordial atmosphere. Primordial atmosphere was there on the Earth's surface, and this primordial atmosphere consisted of various harmful gases which were not suitable for the generation, for the sustenance of living beings, and that's the reason because of which in the initial period when the Earth was forming, there were no human or any animal or plant species which were there over the Earth's surface. You know, how many years it has been since the evolution of a human? What do you think? How many years since we have evolved? Million years. 10,000 years before. We started evolving 10,000 to 15,000 years before, right? Animals started evolving a billion years, millions of years before. But how many years it has been since the formation of the Earth? 4.5 billion years. That means when the Earth was evolving, significant time period of the Earth, that means it's around 60 to 70% time period of the Earth was that time in which there was no animal, no plant species, nothing was there over the Earth's surface, and Earth was evolving only, right? At that particular point of time, we had very harmful gases over the Earth's surface which were not conducive for the development of the animal and the plant species. So obviously we need to remove that atmosphere first of all, then only the suitable atmosphere would be able to come in. But when Earth was evolving, its overall geomagnetism was very weak. Now what is this geomagnetism? Earth acts as a magnet. Do you know that? Earth acts as a magnet. There is a magnetic property which is there on the Earth. Recently there was a news which you must have heard that the magnetic polarity of the Earth is shifting. The north and south pole is shifting, right? Every magnet has one north pole and south pole. The same is true with respect to Earth, and Earth also has its magnetic north and magnetic south pole, and that is continuously shifting in a particular direction, and it keeps shifting. It is said that after every 4 lakh years, this north pole becomes south pole and south pole becomes north pole. That means magnetic north pole becomes magnetic south pole, magnetic south pole becomes, that means there is a complete reversal which takes place after every 4 lakh years, right? It's been 7 lakh years since that reversal has taken place. The reversal was not taking place now. Actually क्या होता है, whenever, see what is this, first of all we will see what is the significance of this magnetism. This is geomagnetic north pole is over here, geomagnetic south pole is over here. Because of this north and south pole, we have a magnetosphere around us. Earth has a kind of magnetosphere around us. Earth is surrounded by that magnetosphere. So whatever harmful solar radiations, solar flares which are coming towards the Earth, those solar flares are filtered from this magnetosphere. And filtered solar radiations are coming towards the Earth. Then those radiation passes from our atmosphere, then they get scattered, dispersed, then ozone absorbs some heat, and then greenhouse gases. So various filtering mechanism takes place on the light which is coming towards us, and then very filtered light we consume over here on the Earth's surface. Imagine if you are standing over here outside Earth somewhere, you are standing over here. If sunlight falls on you, immediately as soon as that would fall, your body would create holes. There would be holes in your body. That sunlight is so penetrative. Just because it gets filtered continuously, that's the reason because of which we get a very filtered light over the Earth's surface. But that happens because we have current atmosphere in which there are suitable gases are there. At the same time, we have magnetosphere which is also defined right now, isn't it? When this magnetosphere changes, reversal takes place. There is a time at which magnetosphere becomes zero, right? The overall intensity, say obviously when this would reverse, there would be a point when the magnetosphere would become zero, and then again it would become strengthened. See, it becomes weaker, zero, then becomes stronger. This way it goes. So whenever it becomes zero, magnetosphere vanishes for some time, and then solar flares can bombard over the Earth's surface. It is said that this is the reason because of which dinosaurs got extinct from the Earth, right? you see sometime that how dinosaurs got extinct. You would see that various meteors started falling over the Earth's surface and all. So from where those meteors came? Those meteors came because right now what happens is, whatever meteor you understand, right, everyone? Whatever meteor which tried to come towards the Earth, that meteor gets broken at various parts of the magnetosphere. That meteor gets broken and very fine particle fall over the Earth's surface of that meteor. So we never realize that some particles which are falling, that might be of meteor. But what happens is, while passing from the thick layer of atmosphere and this magnetosphere, meteor breaks a lot. But what if this magnetosphere would not be there? Then the meteor would fall directly and that meteor would cause a lot of tragedy. So that was the reason because of which dinosaurs got extinct. It is said that this magnetic reversal takes place after every 4 lakh years, right? After every 4 lakh years, this reversal takes place. It's been 7 lakh years over the Earth's surface since the last reversal has taken place. That means the reversal is not taking place, and now it has started. Now it will become, the Earth's magnetic polarity would get reversed. That means there will be a point when the magnetic polarity may become 0, and then again there are chances that then meteors and all those things would fall over the Earth and all. The same extinction process may take place. But again, human is not like dinosaur. We have brains, we have technology, so we may do something or we may not do. That's a different story altogether. What would happen in the future? I don't intend to threaten you or something like that, that you are going to die and all. But this is how it works. The magnetosphere becomes, this polarity would become 0 after a particular point of time. So basically, this magnetosphere is very important for us because this magnetosphere also protects our atmospheric layer. Otherwise, what would happen if the magnetosphere would not be there? Solar flares would come and they would take away our atmosphere from us. All the gases and the dust particles, they would take away that atmosphere from us. But now we have a magnetosphere, so it is there right now, atmosphere is there. Earlier when the Earth was evolving, at that point of time, Earth was in the form of gaseous state. So when Earth was in the form of gaseous state, our magnetosphere was quite weak, and that's the reason because of which whatever gases which were there over the Earth's surface, Earth was in the gaseous state, then got condensed into liquid state and then solid state. So that initial period when that magnetosphere was weak, whatever gases which were there over the Earth's surface, those gases were stripped off by the solar flares. Because this magnetosphere was not there. So whatever sunlight was coming, that was taking out this atmosphere which was there over the Earth's surface. This is the first reason. This is the first step for the formation of the current atmosphere. So there are basically 3 reasons for the formation of the current atmosphere. First, removal of primordial atmosphere by the solar flares, or solar flares, rather you can say solar winds. Second, process of volcanism caused by meteoric impact and resultant degassing, right? And third is process of photosynthesis. These are the 3 reasons for the formation of the current atmosphere. How this primordial atmosphere got removed? Because Earth's magnetosphere was weak, and that's the reason because of which solar winds which used to come towards the Earth, they managed to take out our entire atmosphere from the Earth. So all that earlier atmosphere got removed. But now if everything would become vacant, if the atmosphere is not there anymore, that means now something need to be filled up, right? Now something need to be filled up. That process has started because of meteoric impact. Now what happened because of meteoric impact, guys? See, pay attention. When meteors fall over the Earth's surface, obviously if a huge rock would fall at this particular location, what would happen? Cracks would develop within the surface, isn't it? A big hole would develop in the surface and then the crack would also develop. Because of the development of those cracks, magma started forming and magma started coming out over the Earth's surface. But how magma formed? How this magma has formed? Did we have any magmatic chamber within the Earth's surface which got burst, or the magma formed at that point of time itself? Basically magma formed at the same point where the meteoric impact has taken place. See, let's take one example. You must have seen that LPG gas cylinder at your home, everyone. In that cylinder, whatever propane and butane is there, that is in which form? Liquid, solid, gas, in which form? It's in liquid form, right? It's in liquid form. That's the reason because of it is called liquefied petroleum gas, isn't it? Now, as soon as you open the knob of that burner, that comes out in which form? Gas. Why does that happen? Because you release the pressure. That pressure gets released instantaneously, and that's the reason because of which whatever is there in the liquid form, that comes out from that tube in the form of gases, right? Because the pressure gets released. When the pressure gets released, it converts from liquid to gas. Exactly same thing happens here in this within the Earth's surface as well. Here what happens is, see, first for understanding this meteoric impact, first of all let's understand the concept of superincumbent force. What is superincumbent force? Superincumbent force is the force exerted by the top layers of the rocks on the lower layers. So let's suppose we have rock over here. We have layers of rocks, various layers of rock. All these layers of rocks put some kind of pressure over the surface. They have their own weight, right? And they're putting that weight on the lower surface. That weight which upper rocks are putting on the lower rocks is called as superincumbent force. Now in these all layers, which layer would be having the maximum pressure? The lowest layer. This layer is under maximum pressure, right? This is under a bit lower. So basically they are experiencing some kind of pressure. If you increase the compressive force, if you increase the pressure, melting point increases or decreases? Again, this is quite confusing, right? If you increase the pressure, melting point would increase. What does melting point increase or decrease mean? When I say melting point increases, that means body would take more time to melt or less time to melt? More time. If melting point increases, that means body would take more time to melt, right? It's like this. Let's suppose a given body melts at 20 degrees Celsius. Now if the melting point increases, that means it becomes 40 degrees Celsius. Now rather than melting at 20 degrees Celsius, that body would melt at 40 degrees Celsius. That means now it would take more temperature for that body to melt, right? So when the melting point increases, the time taken for that body to melt would also increase. If the melting point decreases, then time taken for that body to melt would also decrease, right? Are you getting this? But when I say body melts, that means let's suppose initially that body is in the solid state. Let's suppose initially that body is in the solid state and then it melts. So molecules are going apart or coming closer? Apart. Solid to liquid, so molecules of that body is going apart, right? But here what I am doing? Exactly opposite of that thing. I am compressing it. That means I am trying to bring those molecules closer. If I try to bring those molecules closer, in that case it will take more time to melt or less time to melt? More time to melt, right? Now more. It will take more time to melt now. Because I am trying to bring that body closer. Molecules are I am bringing those molecules closer. So they will not go away. So it will not convert from solid to liquid now. So basically melting point increases if the pressure increases. Are you getting this? Melting point increases if the pressure increases. So here when the superincumbent force, that means upward force increases, melting point of these bodies increases over here, so they remain in the solid state. But what happens is when I release the pressure instantaneously, If the huge pressure is applied and when the pressure is immediately released, body immediately changes its state from solid to liquid or from liquid to gases immediately. But that force need to get released instantaneously. So what happens is, let's suppose a meteor comes from above and that meteor falls over the surface. So it would develop huge cracks within the earth. So when the cracks would develop, the place where the cracks have developed over here, the pressure would get released. जहाँ पे crack develop होगा वहाँ पे तो pressure would get released, right? So as soon as that pressure would get released, that rock would convert into magma. The rock would instantaneously convert into magma, and that magma would come out over the earth's surface in the form of lava. The difference between magma and lava is that magma, you call it as a magma within the earth's surface. When it comes out over the surface of the earth, it's called a lava. So that magma comes out in the form of lava. So here everywhere there would be a lava. Everybody understood this? Everybody? It was quite, actually the way I have explained it, it was, you must have read it somewhere in your physics. 100% you must have read it somewhere in your physics. But I've read it long time back, so we don't remember those things. It's very easy, but how melting point is related to superincumbent force and all those things is not that difficult. You again, see, we'll revise it again. What did I say regarding this melting point and all? Increase in melting point would lead to, it would take more time to melt or less time to melt? More time to melt. Because if I compress a body, now here, if I compress the body, I am trying to bring molecules closer or away? I am trying to bring molecules closer. But when the melting point increases, the body tend to remain in the solid state, and when the melting point decreases, body tend to remain in the solid state or in the liquid state? It tend to go into liquid state. That means when the melting point decreases, molecules tend to go away from each other. Solid to liquid, liquid to gases. In each of these states, from solid to liquid, molecules go away. From liquid to gases, again molecules go away. From gases to liquid, molecule come closer. From liquid to solid, molecule come further closer. So when the melting point decreases, solid to liquid, liquid to gases. So molecule tend to go away. When melting point increases, gases to liquid, liquid to solid, molecule tend to come closer. है ना? So if I increase pressure, I am basically, what I am doing is, I am increasing melting point or decreasing melting point? Increasing melting point, isn't it? Increasing melting point. So when this pressure would get released instantaneously, melting point would drop, it would reduce, and body would change from solid to liquid, and the magma would form. The rock would convert into magma. So magma would form over here. That magma would come out over the earth's surface in the form of, but that lava contains huge amount of gases. Whenever lava comes out, that lava comes as huge amount of gases. Nitrogen oxide, sulfur dioxide, carbon dioxide, carbon monoxide. There are so many gases which comes out along with water vapor. So water vapor also comes out. So when this meteoric impact has taken place, see, the first step has done. First step is done. Now we are in the second phase right now. Process of volcanism caused by meteoric impact and resultant degassing. Because of the meteoric impact, the volcanism has taken place. That volcanism led to bringing that lava over the surface of the earth, and lava has released huge amount of gases and the water vapor in the atmosphere. So carbon dioxide and the water vapor started releasing in the atmosphere. See, atmosphere would have carbon dioxide and water vapor now. But a theory hai, which is called as Big Bang theory. That Big Bang theory says that entire universe and the earth is cooling down continuously. But if this is true, obviously yes, that's true actually, earth is cooling down continuously. When the earth cools down, the water vapor, what happens when you cool down water vapor? जम जाता है वो, मतलब वाटर वेपर किस में कन्वर्ट होता है? नहीं, पहले लिक्विड में होगा ना. First it would convert into liquid and then it would convert into solid. So condensation basically takes place. Whenever you cool down a particular water vapor, it would convert into liquid droplets. So what happens is, huge amount of water vapor got released in the atmosphere. But see, earth was cooling down, right? So because of the cooling of the earth, water vapor started condensing into water droplets. So huge number of water droplets formed in the atmosphere and number of clouds have formed. Those clouds started raining. Now rainfall started happening. That means basically whatever water vapor which was there in the atmosphere, that started coming down in the form of rainfall. So water started coming down over the surface. That rainfall kept happening for number of years, millions of years. Whatever carbon dioxide which was released because of this volcanic eruption, that carbon dioxide also started dissolving in that raindrops. When that carbon dioxide started dissolving, so what is the function of carbon dioxide? What do you think? What is the function of carbon dioxide? It maintains the temperature of the earth, right? But if the carbon dioxide would get dissolved, that means cooling effect would take place further. Carbon dioxide जो गर्मी करता है वो खुद ही अगर dissolve हो गया, if the carbon dioxide itself would dissolve, so obviously that will lead to cooling effect. So because that cooling effect, whatever water vapor which was there, they started further condensing, and again new droplets were formed, and again new raindrop kept on happening. Again rainfall, again dissolution of carbon dioxide, and again new rainfall. So basically this is a cyclic process which kept happening for lots of years, and huge amount of rainfall filled up all the depressions which were present over the earth's surface. All those depressions which got filled, they resulted into formation of oceans. See, various seas and oceans formed over the earth's surface, right? So this is the ocean. Now somebody would say कि ocean is ocean का जो पानी है, that is salty, right? But rainfall which happens, that rainfall is of fresh water, isn't it? Basically what happens is that rainfall which is happening, rainfall falls on the land, and from the land it flows towards the depression, but while flowing itself it would bring a lot of salts along with it, and those salts would get deposited. Over the years over the number of years, from millions of years, all those salts would keep collecting in the single depression itself. So that depression again would become salty, right? So that is how that salty ocean has developed. So ocean became salty. All sea water body and the oceanic water body became salty. But somehow in the oceans, the first animal has evolved. Now how that animal has evolved and all those things, we don't know. Nobody knows exactly. There is one, the recent theory suggests that there was a soup of chemicals, a chemical reaction theory is there, and that says that there was soup of chemicals were there. When the soup of chemical is heated for a particular temperature, the cell has evolved from that particular soup. This is what they say, but nobody is clear about how first animal has evolved. So anyways, however that has happened, but in the ocean the first animal has evolved, and that animal had the property of photosynthesis, so it could perform that photosynthetic process. So photosynthesis, when it started doing that photosynthesis, it started releasing oxygen into water bodies, all water bodies, all oceans and the seas. It started releasing lots and lots of oxygen into it. Oxygen release hoga, so obviously animals would evolve into that, and further more animals would evolve, because see, what is required for our sustenance? We require oxygen. That oxygen was present in the water. So all water animals have evolved within the ocean. All water animals have evolved within the ocean. Then over the period of time, the oceanic body got completely filled with oxygen. So obviously, let's suppose you have a bucket, and that bucket got filled up with water completely, and then you tried to put water into it. What would happen? Spill. It would come out. Exactly in the same way, when the oxygen got filled up within the ocean, then ocean started releasing extra oxygen in the atmosphere. So our atmosphere also got filled up with oxygen. So oxygen also started coming out. Over the period of time, when the oxygen was present in the atmosphere, animals started moving towards the land. So amphibians have evolved. Then slowly and steadily terrestrial, so reptiles have evolved, then the terrestrial animals have evolved. So this is how even the animals have also evolved, and this is how our atmosphere has evolved over the period of time, right? So our atmosphere consists of three important things: various gases, dust particles, that is particulate matter, and the third is water vapor. These are the three important components of the atmosphere. So when we discuss this structure and composition of the atmosphere, so composition of the atmosphere stands for these three things. In gases, what kind of gases do we have? Which is the dominant gas we have here? Hydrogen. Nitrogen. What is the percentage of nitrogen do we have? 78% of nitrogen we have over here over the Earth's surface. Why do we require so much of nitrogen? Stability to what? Fire. Stability to fire. Fire requires oxygen for burning, isn't it? है ना? Imagine this way, what we are consuming right now? Oxygen. Right now we are breathing oxygen, right? Imagine if there wouldn't have been any nitrogen or any inert gas, what would have happened? We are breathing but the fire going in and we are breathing out fire. So if we are breathing fire, पूरा अंदर का body चल जाएगा and then human would not be able to, nobody would be able to survive, right? Because of this, in order to control combustible property of the oxygen, nitrogen is required in the atmosphere. That is the most important feature of the nitrogen, because nitrogen is an inert gas. It's an inert gas, it doesn't react with anything. So that's the reason because of which we require nitrogen. What is the other function of nitrogen? It is also taken by the plants and plants. Nitrogen is required by the plants, that is required by the soil. So there are certain nitrogen fixing bacteria are there within the soil, within the plant nodules also, and they fix nitrogen for the plants, and that is required for their sustenance and growth. Nitrogen is very important for the sustenance of the various plants and trees, right? So that's the function of nitrogen. Then second important gas in atmosphere is which one? How much percentage of oxygen do we have? 21%. That means 99% of the total atmospheric composition is made up of nitrogen and oxygen itself. 99%. And we all know what is the function of oxygen. Oxygen is required for our breathing purposes, for living beings, for all living beings. Then the third important gas is which one, guys? Argon. Argon is there in the, which is the third highest component of gas, argon, and the fourth is carbon dioxide. Argon again is an inert gas required for controlling combustible property of the oxygen. So whatever inert gases we have in the atmosphere, they are required for controlling combustible property of the oxygen, right? And okay, so these are the various gases. Other than these important gases, we also have one more gas, ozone. We also have ozone in the atmosphere. What is the function of ozone? It absorbs ultraviolet radiations. It absorbs UV rays, so it doesn't allow those UV rays to follow the surface. That's the reason because of which when we are saying that ozone hole is taking place, so ozone hole is a very dangerous thing. Anyways, we'll talk about ozone hole and why ozone hole is dangerous, then what is ozone hole and what are the reason because of which ozone forms. What are the reason because of which ozone forms and it gets destroyed, okay. So this is about the gases which are there in the atmosphere. Talking about dust particles. So dust particles are required for what? What is the purpose of dust particles and particulate matter in the atmosphere? It forms cloud. Basically, clouds are formed because of this dust and the particulate matter. They act as a hygroscopic nuclei. Hygroscopic nuclei means what? See, for every condensation process to happen, you require a particular surface. Condensation होने के लिए surface लगता है everywhere. You would see even the water vapor which forms, water droplets which forms in the atmosphere. And a fog, you must have seen fog, right? For that fog to form, you need to have particles in the atmosphere. Otherwise, that fog would not form because that condensation process which is taking place, that is occurring near those particles, and that's the reason because of that droplet has formed. Okay, so condensation happens only around a particular particle which need to be there in the floating form in the atmosphere. These atmospheric particles are important for occurrence of rainfall. Okay, occurrence of rainfall, formation of clouds and all. That is the primary function of the particulate matter. And third, we also have water vapor. So we all know what is the function of water vapor, right? So this is about overall composition of the atmosphere. Sorry, composition of the atmosphere. And then after that we have structure as well. There is a particular structure of the atmosphere we have, right? So let's understand structure of the atmosphere. Dust particles? They reduce visibility. Scattering of light, they are important in the heat budget. They are basically responsible for scattering, reflection, refraction, albedo effect and all. So basically they are included under heat budget. So heat budget has nothing to do with visibility as such. Rather they are responsible for heating effect of the Earth's surface. If you observe Earth's overall atmosphere, it is categorized into various layers. So how many layers are there? 5. We have 5 layers. But still, broad classification is 2. Homosphere and heterosphere. These are the 2 broad classifications we have. First is homosphere, in which 3 layers are involved. First is troposphere, stratosphere and mesosphere, and second is heterosphere. In heterosphere we have thermosphere and exosphere. So on what basis do we define heterosphere and the homosphere? Homosphere is basically, on the basis of the chemical composition of the atmosphere, we define homosphere and heterosphere. All the gases which are present, the chemical composition of the gases which are present in the homosphere, they are more or less same. Starting from troposphere all the way up to mesosphere, everywhere you would find that gases are intermixed properly with each other. So everywhere you would find same type of chemical composition. So that's the reason because of which it is called as homosphere. While in the heterosphere, the chemical composition varies significantly with the help of with height. So there would be particular, let's say in thermosphere, the concentration of nitrogen and oxygen is mostly situated in the thermosphere. The concentration of helium and hydrogen is mainly situated in the exosphere. So there are different groups which are already made properly in the heterospheric layer over here. But over here overall chemical composition is same. So you cannot say that this particular gas, this particular, let's say hydrogen, helium, oxygen or something like that, that is concentrated mostly in the troposphere and not in the stratosphere. No, they are mostly equal at all places. Over here they are properly defined. That's the reason because of which it is called as heterosphere, this is called as homosphere. Now let's understand these layers properly. The first layer, starting from the surface of the earth, that first layer is which one? Troposphere. In troposphere, as you go up, the temperature increases or decreases? Temperature decreases. As you go up in the troposphere, temperature decreases. By how much degrees Celsius? 6.5 degrees Celsius per kilometer, which is also called as normal lapse rate. .5 degrees Celsius. It's called a normal lapse rate. It is also called as standard lapse rate or environmental lapse rate. Okay, so all these 3 names are same. Environmental lapse rate, normal lapse rate. Basically this is nothing but change in temperature, decrease in temperature with height in the troposphere, that is called as normal lapse rate or environmental lapse rate or standard lapse rate. Why in troposphere temperature changes or decreases, sorry, why temperature decreases in the troposphere? Because it's because of the heating effect of the earth's surface, heating effect. So solar radiations, so insolation which is falling on the earth gets heated because earth would absorb certain heat and it would get heated. Now once earth would get heated, it would give certain energy to the lowermost part of the atmosphere because that is just touching the surface, right? So that would get heated. But upper part of the atmosphere which is not in contact with the earth, would it be able to get that heat? No. So what happens is, see, it works this way. Let's suppose there is a queue of certain students standing away. Let's say 100 students are standing in a queue, and I am on one end and there is other student on the other end. I have 1000 rupees with me. So what I'll do is, I'll keep 2 rupees with me for my own consumption and I'll pass 998 rupees forward. Then other student, he will again take 2 rupees, pass forward, pass forward, pass forward. Initially, I had how many rupees? 1000 rupees, not 2 rupees. That was my discretion to keep 2 rupees, but otherwise I had 1000 rupees with me, right? But the end person, would he be having 1000 rupees? Because that entire money got distributed among the people. So exactly in this way, starting, let's say insolation, the light is falling on the surface. So surface would get heated. So surface would transfer some of its energy to this lower part of the atmosphere. So this part of the atmosphere would be more warm. But as it goes above, obviously this part of the atmosphere would not be able to get heat from the surface. So it would be colder. So as you go above over the surface of the earth, it would be more cold and cold. So it happens if, let's suppose you go in some building which is on a very huge height, as a 40 or 50 story building. So if you go on that 40th floor, you would feel cold. Most of the time you would not feel as warm as it is there on the first or second floor. Why? Because Earth's heat is directly coming on the first and second floor. But if you go on the 40th floor, over there you would feel cold. Why? Because heat gets distributed. That's the reason because of which the atmosphere temperature decreases with height in the troposphere. 6.5 degrees. What is the height of the troposphere? What is the height of troposphere? It's around 12 kilometer. The height of the troposphere is around 10 to 12 kilometer. 12 kilometer is the height of the troposphere. But this height varies at various locations. Starting from equator all the way up to poles, the height of troposphere never remains equal. Rather, that changes. The height of troposphere at equator is how much? 18 kilometer. 18 kilometer. While the height of troposphere in the polar areas is how much? It's only 8 kilometer. ऐसा क्यों? कहाँ पे? सनलाइट ज्यादा है? कम है. तो उससे क्या होगा? हीट कम है. तो हीट कम होने से क्या होता है? एयर की डेंसिटी कम होती है कि ज्यादा होती है? हीट अगर कम होगी तो एयर वुड बी हेवियर और लाइटर? हेवी. एयर वुड रिमेन हेवी, so it would remain down. If the air would become light, so it would go up. है ना? It's like this. See. Let's suppose this is pole, this is equator, this is pole. This is the height of the troposphere in the equatorial areas. This is the height of troposphere in the polar areas. This happens because, see, obviously, if the sunlight is falling more in a particular area, the heating effect would be more, and more and more air would get expanded. है ना? Because if the air would get more heat, expansion would take, density would reduce, and the air would start rising up, isn't it? Density of the air reduces, right? When you give heat, air would expand. Heat देने के बाद air expand होगी ना, तो density would reduce and air would become light. Lighter air would go above. So because of that, more and more air tend to go up. That's the reason because of which on the equator, because heating effect is more, the height is more. While on the polar areas, heating effect is less. Overall heating effect over there is less. That's the reason because of which air stays down. So overall height is less over there. So its height in the polar area is 8 kilometer, while height of the troposphere in the equatorial areas is 18 kilometer. 8 kilometer and 18 kilometer. This is the difference in height. There is second reason as well. There is second reason as well for this. Centrifugal force. Centrifugal force is what? Outward acting force. So atmosphere which is present over here, don't you think इसको बाहर खींचने वाला force ज़्यादा होगा? Centrifugal force on the equator is maximum, right? On the polar it is less. बताया था ना मैंने centrifugal force, I have already told you. So outward acting force on the equator is more. That's the reason because of which air tend to go out. While on the polar areas, that outward acting force is less. So air tend to stay down. That's the reason because of which on the equator, height of the troposphere is more, while height of the troposphere in the polar areas is less. Okay. But on an average, the height is considered as 12 kilometer. So what is the property of troposphere we have seen? In the troposphere, as you go up, temperature decreases by 6.5 degrees Celsius per kilometer. The height of troposphere is 12 kilometer, but that height varies at various latitudes, and equator its height is 18 kilometer, while in the polar areas that height is 8 kilometer. Right? Most of the atmospheric phenomena, that means around 90 to 99% of the atmospheric phenomena are concentrated in the troposphere. Troposphere means सारी atmospheric phenomena. Atmospheric phenomena means what? Means what? Cyclone, anticyclones, and jet streams and all. Most of the atmospheric phenomena are situated in the tropospheric layer. तो stratosphere में भी नहीं, stratosphere में एकदम कम होता है, mesosphere में तो होता ही नहीं है, ठीक है? Most 80% of the atmospheric density is situated in the tropospheric layer. Right? These are the properties of the troposphere. And one more significant property of this troposphere is that, see, if you come at the equator, on the surface of the equator and the surface of the pole, where do you think the temperature would be less? Pole पे तो कम temperature होता है ना. On the polar region temperature is less. But if you go at the top of the troposphere, मतलब यहाँ पे, let's suppose this is equator, this is 90 degree north. If you stand over here, the temperature at the polar area and the temperature at the equatorial area, so it may happen that the temperature at the equator might be 25 degrees Celsius, but the temperature at the polar area might be minus 10 degrees Celsius. Correct? So temperature यहाँ का कम होगा on the surface, but as you go above, up, यहाँ पे, at the top, that means near tropopause, the situation gets reversed. The temperature at the top, near troposphere, at the top of the troposphere in the equatorial areas, that is lesser than the temperature at the top of the troposphere in the polar areas. ऐसा क्यों? Height ज़्यादा है ना? तो let's suppose यहाँ पे 25 डिग्री सेल्सियस है, and then height is 18 kilometer, right? And there is per kilometer there is change of 6.5 degrees Celsius. So 6.5 degrees Celsius, 25 minus 6.5 minus 6.5 minus 6.5. That subtraction would happen for how many times? 18 times, because it is 18 kilometer over here. Minus 10 degrees Celsius. This minus 6.5 degrees Celsius minus, that subtraction would happen how many times? Only 8 times. 18 times, 8 times. So 18 times hote hote, subtraction, if it happens for 18 times, don't you think temperature would go further less? Temperature would become very less over there. So here temperature is considered to be around minus 60 degrees Celsius, while temperature over here is considered around minus 50 degrees Celsius. Right? So this is the property of the troposphere. These are the properties of the troposphere. Now let's go in the after troposphere we have one transition zone called as tropopause. This is troposphere, and there is a tropopause over here. Okay. Now after that we have one more layer called as stratosphere. So in the stratosphere temperature increases or decreases as you go up? Increases. In the stratosphere temperature increases. But this increase in temperature does not remain, it's not like this that temperatures start increasing from the first point of the stratosphere itself, from the lower part of the stratosphere itself. Rather, it is observed that in the stratosphere temperature remains constant for some time and then it starts increasing. So here basically temperature remains constant for some time and then temperature starts increasing. So in the stratosphere there is a particular layer only in which temperature increases. Why temperature increases in the stratosphere, guys? What do you think? Ozone. Ozone is there. What is the height of stratosphere? 50 kilometer. 50 kilometer. 50 kilometer is the height at which, like, up to which the stratosphere is there. Starting from this 25 kilometer all the way up to 55 kilometer, you would be able to find that ozone concentration. The layer in which we have ozone, that layer is called as ozonosphere. The layer in which we have ozone, that is called as ozonosphere. Now this ozone is responsible for absorbing UV light. What is the reason because of which ozone forms and it gets destroyed? Basically it is the sunlight which is the reason because of which ozone forms, and it is the sunlight because of which ozone gets destroyed. Ozone forms the sunlight, sunlight forms the ozone and sunlight destroys the ozone as well, right? Whatever, because of this, the region in which we have more sunlight, in that particular area maximum ozone would form, and the region in which we have least sunlight, over there least ozone would form, है ना? So tell me one thing, starting from equator all the way up to polar areas, in which area do you think the overall ozone formation would be highest? Equator na, formation would be highest in equator, although concentration is highest in the polar areas. ऐसा क्यों होता है? ठीक से ध्यान देना, यहाँ पे देखो होता कैसे है. Again I will draw the diagram of pole and equator. As I said, this is 90° north, this is equator. Height of troposphere is higher in the, कहाँ पे? In the equator, while height of troposphere is less in the pole. अब नीचे से नहीं, इसको ऊपर से देखो, from here, from stratospheric angle. Stratosphere starts late in the equator, while it starts early in the polar areas. So there is a kind of gradient which is there in the stratospheric, lower stratospheric layer. मतलब ऐसे एक gradient की तरह है वो, isn't it? This gradient is there in the lower part of the stratosphere. So what happens is, as sunlight is maximum in the tropical and the equatorial areas, most of the ozone layer forms over here. तो यहाँ पे maximum ozone बन जाता है. Ozone forms over here. But just because there is a gradient which is present over here, so obviously Earth की gravity खींचेगी ना उसको नीचे की तरफ. Earth's gravity would pull it downwards. So this gravity pulls this ozone towards itself. That's the reason because of which ozone starts moving towards polar areas, and then it gets accumulated in this polar region. Ozone gets accumulated in the polar region. But the problem with polar areas is that polar region में sunlight तो आता ही नहीं है. There is hardly any significant sunlight which is there in the polar areas, right? So if we have very less sunlight over there, there is no one who would be able to disintegrate those ozone particles. So ozone molecules would not get disintegrated over there. So ozone यहाँ पे बनता तो नहीं है. In polar areas, ozone doesn't form, right? But it doesn't get destroyed either. And whatever ozone forms in the tropical areas, that comes all the way up to polar areas. So basically polar region is acting as a collective agent. It keeps collecting ozone continuously. That's the reason because of which, although ozone gas forms mostly in the tropical and the equatorial areas, it is mostly present, most of the ozone is present in the polar areas. Most of the ozone is situated in the polar areas. But still you would say कि भाई ozone hole कैसे हो गया फिर polar region में? So it's because of us. We are releasing huge amount of industrial pollutants and all. That's the reason because of which ozone hole happens in the polar region. But the point is, why only polar region? See, industries polar area में है क्या? Industries are where? Here. It's there in the tropical areas, temperate areas, because most of the countries are situated over here, right? Whatever pollution which you release from here, so ideally, immediately ozone which is present over here in the stratosphere, that should get depleted. But ये खत्म नहीं होता है. कहाँ पे होता है? Ozone hole happens in which part? Polar region. Why? Why do you think that happens? So we have to wait for this one. In order to answer this, we'll wait for this, because we have just started. So you don't know what is jet stream and all, maybe. As of now, you don't know what is jet stream. So you would not be able to understand it properly. So when we will discuss jet stream, at that point of time, I'll explain you how this jet stream and all that helps in bringing all pollutant toward polar areas, and how it results into depletion of the ozone and all those things. Okay. So this is how ozone forms and it gets concentrated. So basically, stratosphere is known by what? Stratospheric layer is known by constant temperature up to particular height and then increase in the temperature. Yeah? And there is a particular layer in the ozone is there. So ozone is responsible for increase in temperature in the stratosphere. Although we say 99% of the atmospheric phenomena occur in the troposphere, right? That means something is happening somewhere as well. तो वो होता है stratosphere में. In the stratosphere, we have certain clouds are seen in the stratosphere. Those clouds are called as cirrus cloud. Cirrus clouds can be seen in the stratospheric layer. And those clouds are mostly present in the lower part. But those clouds are so fine that their overall presence is negligible. But still cloud to hai. If the cloud is forming, that means what? Some atmospheric phenomena must have been there. That's the reason because of it is said that very fine, minute atmospheric phenomena occurs in the stratospheric layer. Okay, otherwise mostly it happens in the troposphere. Just because atmospheric turbulence is least in the stratosphere, in the lower part of stratosphere, that's the reason because of which supersonic jets which are there, they move from stratosphere. For that matter, even some of the planes also go all the way up to stratosphere and then they move from there, because then they can cut down that atmospheric turbulence altogether. Okay. Then after stratosphere, there is stratopause. Obviously, can you tell me this? Why do we require this tropopause, stratopause? Because after decreasing temperature, the temperature increases over there. तो ऐसा तो नहीं होगा ना? After particular point itself, immediately temperature starts increasing. There must be a transition zone for decreasing, from decreasing to increasing trend. There should be a transition zone, right? That transition zone is defined as tropopause, stratopause, mesopause, that way. Now after stratopause, temperature decreases. That decrease in temperature happens in the mesosphere. This is called a mesopause. Why temperature decreases in the mesosphere? Because there is nothing over there. No gases actually. There is no significant gas which would be able to absorb that heat for mesosphere, and the temperature would increase. So here temperature basically decreases. In the lower part, although some ozone molecules are seen. So ozone basically absorbs heat for it. So that's the reason because of which in the lower part heat is more. As it goes up, temperature decreases. Right? In the stratosphere, at the upper part, देखो यहाँ से temperature कितना था यहाँ पे? At this point, minus 50, minus 60 degrees Celsius I have told you. Now by the time it comes over here, the temperature becomes minus 10 degrees Celsius to 0 degrees Celsius. But when it goes all the way over here, in the mesosphere, temperature can be minus 130 degrees Celsius. It is the coldest temperature which can be seen in the entire part of the earth, everywhere. पूरा ऊपर से लेके नीचे तक, everywhere. Even in the Antarctic region also such cold temperature cannot be seen. Mesosphere contains the coldest temperature of the entire atmosphere. Okay, so temperature decreases over there as you go up. Mesosphere is also one layer in which when the meteor starts coming towards the earth's surface, meteor starts burning over there firstly. Meteor आता है ना earth के ऊपर. When the meteor starts coming towards the earth, while passing from, you must have seen that while coming towards the earth, meteor starts burning. Why do you think the meteor burns? Friction. Those rocks, the meteoric rocks, the friction occurs for the meteoric rocks and those rocks starts burning, right? So that burning takes place from the mesospheric layer. So while coming down, it starts burning from mesospheric layer. These are the significance of the mesosphere. After mesosphere, you have thermosphere. What is the significance of the thermosphere, guys? Ions. What is the height of the mesosphere? 80 kilometer. Right? 80 kilometer. And what is the height of thermosphere? 650 kilometer. So what is the significance of thermosphere? Temperature increases over there. But why temperature increases in that particular area? Because ions are situated. The region in which ions are there, that is called as ionosphere. So ionosphere is basically present up to what to what? So ionosphere starts from 100 kilometer and that goes all the way up to 650 kilometer. So ions are present in that particular area. Ions of what? Ions of nitrogen and oxygen. Although the oxygen is there over the earth's surface in the troposphere, but most of the oxygen is concentrated in the thermosphere. Most of the oxygen. That means whatever oxygen which we have for breathing, that is very minute. Out of that 21% of the oxygen which we have in the atmosphere, most of the atmospheric oxygen is there in the thermosphere. Okay, so it's because of the ions of nitrogen, oxygen, the temperature increases over here. And then finally we have exosphere. Now in exosphere also temperature increases as you go up. But why temperature increases in the exosphere? Because hydrogen and helium is concentrated in the exospheric layer. Hydrogen and helium is concentrated in the exosphere. That's the reason because of which hydrogen and helium directly absorbs heat from the sun's light, and that increases the temperature of the exosphere. This is the reason because of which temperature increases in the exosphere. So these are the different layers of the atmosphere: troposphere, stratosphere, mesosphere, thermosphere and exosphere. Right. So this is about structure and composition of the atmosphere. Today's lecture was very basic as such. All the things which we have covered, that is there in your NCERT somewhere or other. It's very basic. So it's there in your notes. We have not written too many things because this is quite basic in nature. Obviously that would be there in our notes. The first topic which we have covered, fundamentals of geography and all, that is not there in your notes. So what I will do is I will send you PDF file for that. From next lecture itself onwards, what we will do is we will start forming WhatsApp group बना लेंगे एक, and that whatever notes which I feel that it's very important for you and it's not there with you, then I'll send you PDF file for that. ठीक है? Then that will start from next lecture onwards. Tomorrow on Monday onwards. Yes, you were saying something.
Height or the extent of stratosphere 50 km? Is it height from the ground or is it the extent of?
From the ground.
50 km
From the ground. है ना? चलो, let's stop here.